Welcome to Chapter 2, Chemical Changes and Chemical Properties. Again, we're still talking about matter. Last time we talked about how matter looked, what it did, and we didn't change the matter itself other than maybe change the way it looked in its form, but the molecules themselves stayed the same. In this video, we're going to talk about how matter actually changes on the molecular level. So, just to review, we classify matter by its physical properties and its physical changes. And now we're going to talk about matter's chemical properties and its chemical changes. Starting with chemical properties. So, a chemical property, you can't really see this. And you can only observe a chemical property when it's actually happening in a chemical reaction. So this is a huge part of chemistry, see, because it's chemical reactions. So the first thing we want to look at are the examples of a chemical property. One example is called heat of combustion. We'll get to this more when we get to this thermodynamics chapter. But the heat of combustion is, by definition, the amount of energy needed to get something to burn. So take this propane tank, which we know contains propane. How much energy does it take to get that thing to burn? Another one would be heat of formation, or enthalpy of formation. How much energy does it take to get something to form? In this case, we have oxygen and hydrogen molecules forming water, and it takes a lot of energy. Well, I should say a lot of energy is released when this guy's formed. One way to determine a chemical property is to ask yourself, what can a substance do? In this case, we have the example of being toxic or toxicity. And, we define a chemical by what kind of damage can it do to you? Is it a toxic chemical? For example, lead poisoning. We heard a lot about this in Flint, Michigan. They had lead in the pipes getting in the water. It can cause all kinds of problems, especially to children. Lead, then, is considered to be toxic. Is a chemical stable? For example, if you take iron, leave it outside for a while, it's going to rust. Another word for rust would be corrode. So what we're looking about for chemical stability is more, what can it do? The amount of energy needed to get something, in this case, to corrode. Iron, under some situations, can be corroded. Another one that's cool, I know this is called elephant toothpaste, and it's whether or not something will decompose. Will it break down? And the key thing behind this is the decomposition of hydrogen peroxide. It's kind of cool, isn't it? Maybe we'll get to do that one in class. It's a lot of fun. Just kind of a mess to clean up. Another one that determines chemical stability is the amount of energy needed to get something to form, to make. And this is polymerization. Isn't that a fun word to say? Polymerization. Another chemical property would be, can a substance burn? Can it react with an acid? In this case, I have magnesium in hydrochloric acid, and we get hydrogen gas. But not everything will react with an acid. For instance, the copper here doesn't do anything. Some substances can react with water, and we can define them in that way. So if it reacts with water, if you take sodium metal, which is soft, you can cut it with a butter knife, and you put that thing in water, watch this. Booyah! Oh yeah, it explodes. We'll play with sodium later. I talked about this briefly. Can it react with oxygen? That's another way we define a substance, if it reacts with oxygen or not. In this case, it's corroded or rusted. Not everything will do that. Some elements react with other elements. Again, we have sodium metal. I put it in chlorine gas and I get table salt. This is a really violent reaction. Watch this. Yeah. See it again. Sodium in the chlorine gas, boom, and you end up with table salt. So let's review. Matter, you can define it based on its physical properties, boiling point, melting point, density, which I didn't mention, but it's there. That describes the characteristics of matter, sort of like the personality. And the physical changes, those do not change the composition. Like if you boil or evaporate or sublime or dissolve substances, it's still the same stuff. Chemical properties, we define those based on what a chemical can do. Now we're going to talk about chemical changes, which is really the heart of chemistry. The key to determine whether or not something has undergone a chemical change is if the molecular arrangement has changed. So if you take a look here, I've got little red balls, little blue balls, and when it goes through a chemical reaction, you end up with a different arrangement. In this case, water. And it's completely different than what it started with. So here we have hydrogen molecules, oxygen molecule, combines to make water, and you can see the little ball arrangement, the molecular arrangement is changed. That's a chemical change. There's the chemical formula if you really want to know. On the previous slide, I said there's the chemical formula if you really need to know. And what I really should have said is that's the chemical equation. I said the wrong word. I'm sorry. I got that changed. All right, so chemical change, rearrangements. Here you can clearly see that we have a molecule of blue. Yeah, I need my pen. And then we have two atoms of red. And when they combine, look at this, not even do they get rearranged, but the size of the atom, in this case they're ions, but they change. The key point, rearranged. Something brand new is made, and it's really hard to get it back the other way. There's several different types of chemical reactions, and later in chapter 8 we'll talk about these types of chemical reactions in more detail. But if you take an acid and a base and combine it, you can see that hydrogen has dumped chlorine, potassium has dumped, this is called hydroxide, and look, they've changed partners. Potassium has now hooked up with chlorine. And hydrogen has now hooked up with hydroxide to make water. Another type of chemical reaction is called a precipitation reaction. And precipitation basically is a fancy word for a solid, but the particles in the solid are so fine it almost would look like a powder. It doesn't look like a solid like your pencil. But look at this. If I take this liquid and combine it with, oh, where'd my pen go? Oh, there it is. This liquid, we get this precipitate, this solid substance forming, and it would eventually settle along the bottom. Again, to do that, it's rearranged. The molecular arrangement changes. Another type of reaction is called synthesis. In a synthesis reaction, you make something. Make something brand new. So here we have iron hooking up with elemental oxygen to make iron oxide. Well, this is actually called, iron oxide. And you know, it's brand new. Brand new. In a decomposition reaction, two things are made. It's like the opposite of synthesis. Something breaks down into something brand new. So the egg broke down into now eggshells and a turtle. Except I think it would actually be a turtle. My biology is rusty. I'll go on. Here we have mercury oxide breaks down into mercury metal and oxygen gas. In a combustion reaction, notice here we have carbon with some oxygens hanging out. Here we have two oxygens, and on the other side of the reaction, rearrangement. Something brand new is made. Another type of reaction, single displacement. See, A was dating B, and C thought B looked pretty hot, so started a rumor. And now A is all alone, and C is finally hooked up with B. It's just like high school. Oh, my pen's not working. Try it again. B. There we go. Next, we're going to talk about the different types of matter.